All right, y'all. It's a panic day. Fractions. I know. I know. It'll be all right. But today I want to teach you how to find the square and cube roots of fractions. Write this as the title on your next free page in your math notebook. When you have done that and closed it up and stopped panicking like the frog here, concentrate with me until we get to we do. All right, so real quick, square and cube roots we've been working on. Things like what can be multiplied by itself to make 100. So that could be 10, or it could be negative 10. Cube roots are whatever would be multiplied by itself 3 times to make it. This would be 10 times 10 or negative 10 times negative 10. And then cube roots, of course, 3 times. That's like what times itself 3 times makes 1,000, which is also 10 in this case. So that's going to be important. Multiplying fractions also important, just so we're dealing with fractions today and roots and multiplying and stuff like that. Multiplying fractions, don't forget, that is the easy fraction operation. All you've got to do to multiply fractions is multiply the numerators, multiply the denominators, you're done. So that's going to be important today too. So here we go. X squared equals a fourth. Yuck. So x equals what? So like I said yesterday, remember, square roots are the inverse operation of squaring. So when I see a question like this, I'm trying to figure out this, right? What number it's going to times itself makes 1/4. That can be tough to do just by common sense alone. It can be a hard thing to do. So as always, what we would do, thinking back to last time, we would say, okay, well, if I think algebra E here, x is being that is square root. So x is going to be whatever the square root of 1/4 is. That looks really scary, intimidating, and difficult, but I want to show you what you can do. The way square roots work, you can actually find the square root of 1/4 by finding the square root of the numerator and the square root of the denominator separately. You don't have to find it of the whole fraction. Math doesn't always work this way, but sometimes you can just do that and say the square root of the whole thing is the square root of the numerator over the square root of the denominator. That works, and that's actually pretty easy. The square root of 1 is 1. Square root of 4 is 2. Wait, what? Square root of a fourth is a half? Can that be right? It is, because if you take a half squared, half times half is 1/4. So its square root is actually half. Only little thing to remember when we look here and say, okay, so the square root of a fourth is a half, don't forget it also could be negative a half, because negative a half times negative a half is also positive a fourth. So just don't forget when you do square roots and they're positive, they have 2, the positive one or the negative one. Another one, same thing here. Well, this looks even worse. Like 1/4 isn't even a scary fraction. 49 121ths. That's a pretty intimidating fraction. But same process. The inverse operation of squaring is square rooting. So C is going to be whatever the square root of that scary looking fraction is. Like I told you last time, you can find that by finding the square root of the numerator, which we can do, and the square root of the denominator, which we can do separately, and that turns out to just be 7/11. Not really so bad when you think of it that way. Or, of course, don't forget negative 7/11 could be it as well. But if you did 7/11 times 7/11, if you want to check, you'd get 49 121st once. I don't know how you say it. So it's really not so bad if you know this. The square root of a fraction, you can do the square root of the numerator and you can do the square root of the denominator. It's not always quite so nice. Like when we look at a fraction like 4/15ths, if I do square root on both sides, x is going to be the square root of whatever 4/15ths is, which is going to be the square root of 4 over the square root of 15. That numerator, no problem. that denominator we don't know. That's not a perfect square of 15. And so I can't really, I don't want to put a decimal down here. This is going to be like 3.9, on and on and on. You don't want to put a decimal in a fraction. That doesn't really, math people just don't do that. So in that case, what you do with the fraction, usually the convention is you just leave it and just say it's 2. If you can do the square root, do it. If you can't, just leave it as the square, whatever the square root of 15 is. That is usually the convention, is to just leave B, the parts you don't know. And of course, it could be the negative version of that too, since we're dealing with square roots, don't forget. So that's how it works. Open your math notebook. Let's do 3 together real quick so that you don't get terribly intimidated by these in the future. So let's start with one that comes out nicely. A squared equals 4/25. So to find A, I would find the square root of both sides. A is going to be that. That looks super scary. How in the world could I ever know the square root of the fraction 4/25? Well, turns out you can do it this way and say, well, if I know the square root of the numerator, which I do, and I know the square root of the denominator, which I do, then I can take those square roots separately and just get 2/5. Or, of course, don't forget, square roots of positive numbers, and that's a positive number, could also be negative 2/5. If you want to check, it just seems impossible. How could that be the square root of that? But it is. 2/5 times 2/5, if you want to double check, is 4/25. It is. So it's not really like a terribly scary thing to do after all. Sometimes you don't know both the numerator and the denominator. So like this one, I want to do the same way. Square root on both sides. B is going to be whatever the square root of 8 over the square root of 49 is. I don't know the square root of 8. Square root of 9 is 3, so it's a little less than 3. But I don't know that one, so we usually just leave it. So just say whatever the square root is over, this one we do know. Square root of 49 is 7. So I know this looks probably even worse than the beginning thing, but that's the convention, is if you know the square root, do it. If you don't, leave it. Or it could be negative that, whatever the square root of 8 is over 7. Because if you don't leave it, we should probably even write that. Just leave it. If you don't leave it, you're going to end up with some kind of decimal in your numerator. And a decimal in a fraction is just we don't do that. So don't do that. All right, cube roots work the same way, except instead of taking, this is into the third power, so the inverse operation is not a square root, it's a cube root. So I need to take the cube root of both sides. And same thing, so it's going to be negative. Cube root of a negative number is going to be a negative number, and it's whatever the cube root of 8 is, which I know, over the cube root of 27, which I also know. And that'll give us, let's see, the cube root of 8 is 2. Cube root of 27 is 3. And don't forget, it's going to be negative since that was negative. It's 2/3. So 2/3 times 2/3 times 2/3 would give you 8/27. So finding cube and square roots of fractions is actually not as bad as it seems, because if you know the square root, you just do it, and if you don't, you just leave it. And that's all there is to it. So I hope this makes a lot of sense to you. I hope you feel good about it. I hope you feel like you learned something that you can handle. If you need to give this video a second go, please do so. And when you feel super confident that you're ready for class, I'll see you tomorrow.